Hello everyone, welcome to our event. This event is brought to you by Data Talks Club, which is a community of people who love data. We have weekly events and this is one of such events. If you want to find out more about the events we have, go to, there is a link in the description, check this link and you'll see all the events we have. Then if you haven't subscribed to our YouTube channel for some reasons, do it now. This way you will get notified about all our videos on our channel. And then last but not least, join our amazing Slack community where you can talk to other data enthusiasts. During today's presentation, you can ask any question you want. There is a link, pinned link in the description in the live chat. So click on this link, ask your question, and I will ask Rahul all these questions at the end. At the end, right? Or you prefer me to interrupt you and ask? What's the best way?
Yeah, I think you can interrupt, in between. Let's go that way.
Okay, then I will interrupt you. And I finished the introduction. Now the floor is yours.
Yeah, thanks, Alexei, for inviting me again. I think this is second time we are talking in this platform.
It is.
So I really loved, first interaction where we talked about data engineering manager role, right, and responsibilities. I think now I am so excited to talk about modern data warehouse architectures. So yeah, I think let's get started.
Yeah, remember the last question you received on the podcast? It was a pretty long one, and you said it will require an extra hour. So now you have this hour.
Yeah, it's that time now. Yeah. Should I go ahead and share my screen and start?
Yes, please start. Sorry, I thought
okay.
I didn't know you were waiting for me to say that.
Okay.
Yes, please start.
Okay, just a quick check. Can you see my screen here?
Yes.
All right. So again, I welcome everybody and thanks for taking out time and joining this session. And we'll keep it very simplistic and we'll start from basics, right? And to give you some context, right? Today we are going to talk about how modern data warehouses looks like and how the data landscape has changed in quite some time. And that's why there is a need of some newer architectures. So in order to understand that, we have to first look into traditional data warehouse design. What used to be. It's still some companies and enterprises are using this design because this works for them. And so once we learn about this, what is existing or the previous or traditional data warehouse design, then we will see why there is a need of re-architecting few components, right? What is really changing in data ecosystem? Then you will be able to embrace, why we need some modernization in the architectures, right? So as I mentioned, Alexei, please feel free to stop me whenever you have any question or you see any question on the chat window from our viewers or listeners, right? All right. So I think most of you who come from a data warehouse or data background, you might be aware about this diagram, right? And this is typical data warehouse architecture. And it used to, it was working since quite some time, since a couple of decades. It was working fine because our data volume was small, let's say, and it's more relational in nature, right? Very structured data volume, and we had limited data sources. Some of the, let's say, internal operational systems or some flat files, right, which we were interested in. So I'll just quickly, tell you in theory what data warehouse is, right? So within the organization, we have different source systems where particular organization stores the data, right? It could be, for example, it could be any Oracle systems or Salesforce, right? And some marketing department, they have different source systems, and different business units have their own applications and databases to store the data. Now, these could be transactional system, where you maintain transactions like orders, etc., directly serving the front-end applications. Some systems could be more internal for marketing teams, etc. So what data warehouse does is, right, and what our aim to build data warehouse is to pull data from all the source systems within the organization and some third-party data sets, which are very common and which you think can be helpful in order to run some analytics, right? So we pull data from all these source systems, right? And we put into some kind of analytical processing system, which is called OLAP systems in technical terms. And then, so this is kind of a data warehouse where we pull data from all the source system and load into data warehouse, right? And then you have some consumers who consume data from data warehouse. It could be your reporting needs, right? And some visualization you want to run. This is a typical need of data warehouse, right? So that once you gather data from all the source systems, you put in the centralized location, then you have one place or one source of truth to access the data across the organization. If, let's say, data warehouse would not have been in the picture, then you would have directly connected to these source systems to generate analytics, reporting, or some kind of advanced data mining or forecasting, right? That's a typical data warehouse, how it works, right? So I have mentioned few pointers here, how it used to work when were dealing with, let's say, small data sources, mostly relational in nature, structured data set, very limited data sources you had, and very few consumers as well, right? On the right-hand side, you see the data consumer. And typically this data we used to bring in the data warehouse in the batch mode, once daily or maybe twice in a day or once in a week, something like that, based on the business use case. And mostly these systems used to be on premise. I'm talking about traditional data warehouse design, guys. Okay. And we had a lot of predefined reports, templates, right, which were required. So when we had these kind of requirements, right, in those cases, the data warehouse design, which you see in this diagram, right, it used to serve the purpose pretty well. So I'll just explain quickly. So on the left-hand side, you see source systems. Within the organization, it could be internal or external source system as well. And you have some kind of ETL layer, which is called extract, transform, and load. So you extract the data from the source system, you put into the staging area, right, somewhere in between, and you run some kind of transformation, aggregations, right, and load data into the data warehouse. Within your data warehouse, we have some kind of data marts, we call it. You can think of data mart as a subject areas as per business needs, right? So like summary data, raw data, or could be like purchasing, sales, different subject areas wise. You just group the data and combine it. And then these users, analytics, reporting, and mining, these users used to connect to these data marts and generate some reports. It's a typical flow, right? This has been working fine since quite some time, right? And to give you some examples so that people can connect to it. So these data sources could be in terms of tech stack, right? So these could be like Oracle, SQL Server, and flat files like FTP locations, right? Or shared drives as part of source systems. And ETL, some of the enterprise ETL worked really well, like Informatica, Talent, or SSIS, Microsoft Stack. And in data warehouse, you could have just provisioned Oracle or SQL Server or DB2 traditionally, right, as a data warehouse. And for reporting, we had SSRS or Tableau, ClickView, all sorts of reporting tools on our disposal, right? And this used to work perfectly fine. But since quite some time, right, this with the evolution of big data, right, we all know a lot of data is getting generated by machines, by social media, human interaction, or digitalization initiatives, right? So we are getting a lot of data generated, and that is changing this typical data warehouse architecture, because this architecture is not able to serve the need for some other newer trends. So in this slide, typically I'm showing 4 different parameters, how data landscape is changing, right, across the digitalization initiatives, or let's say across whole IT software ecosystem, right? So if you think on the left-hand side, earlier, traditionally, we had very few data sources, as I mentioned. Now we have variety of data sources. So our IoT, sensor data, time series data, like all these data coming into picture, social media reports, right? Everybody is generating huge amount of data on daily basis, right? Whether it's individual, whether these are machines, organization, whatever, right? So variety of data sources we have now. On other note, right? Earlier we used to provision data warehouse in batch mode. So basically processing data once in a day with typical ETL jobs running, populating data warehouses. And we were okay with day -1 or, day minus week kind of reports, right? After the fact reports. So that batch mode used to work fine earlier. But now, since this analytics needs are increasing, so what we need batch mode still, processing data in batch mode. Another thing is we need to process data. There is a need to process data in event mode as well. It's called event driven architecture. We'll talk about it in quite some time. And there is a need of real time data processing as well, because we cannot afford latency. Where the actions are happening, we just want to know at the real time what's happening, right? So batch, event, and real time, these three kinds of data processing are coming into picture these days. Talking about next item, ETL to ELT, right? So ETL typically stand for extract, transform, and load. So this was a typical data warehouse design where you extract data from source system, you transform the data based on your need, and load it in the data warehouse. But nowadays, with evolution of big data and different needs for the consumer side, we are moving towards ELT, which is you extract the data first and you load in the data warehouse or database, and then you transform it. And infrastructure wise, it was possible because we have a lot of compute power these days in the database itself, which was not possible earlier in case of on-premise. So now we have cloud computing and products like Redshift, Snowflake, and BigQuery. These are the cloud data warehouse solutions where you can run a lot of transformation and push that computation at the database level. So these days, most of the data engineers preferring extract, load, and transform. And we'll discuss more about this architecture in some time. The fourth thing which is changing is earlier we used to deal with a lot of structured data sets, right? Which are more relational in nature, like row and column or tabular format, right? And nowadays we are dealing with structured data, but a lot of semi-structured data like JSON or XML, right? And also unstructured data, which is more textual format or voice conversion, etc. And still want to be able to onboard this data and run some analytics on top of it. So if I summarize this, how this trend is shifting, right, from traditional days to modern world is from fewer data sources to more and variety of data sources. From batch processing, we are shifting towards batch plus event based plus real-time data processing. From ETL to ELT, this trend is shifting. Another thing is from structured data, now there is a need to process structured, semi-structured, and unstructured data. Looking at this trend shift, the earlier traditional data warehouse design was not able to fulfill these needs, which we have seen. There are various reasons, right? Because it's not scalable up to that extent. And these tools and technologies which we were using are not compatible with these trend changes, right? That's why there is a need of modern data warehouse design. And that's what we are going to see in the next slide. So looking at this, a lot of component you see here, don't overwhelm with this. I'll explain one each and everything step by step. Okay. So again, in this modern data warehouse design, as I mentioned, you will be able to relate to it, and I'll with the previous slide, and I will keep switching, toggling between previous slide and this slide, right? How these latest trend shift in terms of data or big data, right? This is driving modern data warehouse design. All right. So on the left hand side, again, you see a source systems. So in this box, rectangular box, I'm showcasing the traditional source systems like Salesforce, Oracle, or FTP servers, right? Which we saw in the first slide as well. Along with this, some newer kind of source systems are there in the picture, right? And there's a need to collect data from these source systems. These could be like API endpoints, right? There is RESTful APIs where you want to consume data from. It could be your cloud location. For example, let's say S3 bucket or Azure Blob Storage. right? Which was not there earlier in traditional data warehouses. Another kind of source systems are IoT devices, which are constantly generating and emitting the data. So you can now see there are a variety of source systems are there in this picture, where from which you want to import the data or extract the data and load into your data warehouse. So some of the traditional methods in the batch mode, right? These doesn't work in case of, let's say, S3 Cloud Bucket or IoT devices, right? Because these devices are generating data constantly in the real time. So what you need, as I mentioned in this last slide, from batch processing, you need combination of batch event-based as well as real-time processing. So if you see in this diagram, typically for the traditional data sources, you can these you can process in batch mode. And here I'm showing something. This is a new term called generic ETL, right? And I'll talk more about it. What is generic ETL and what is metadata driven ETL. And so in batch mode, you can just connect to these sources, process the data, right? And again, load into staging tables or staging databases, right? Perfectly fine. You can schedule these ETLs using various scheduling tool available in the market. And also you can hit any RESTful web services in the batch mode, and you can just extract the data and load into staging databases. Now comes the event-based processing, right? So let's consider a scenario, right, where you have some contractor or let's say third-party vendor, which is pushing their file, and you want to consume that data file and load into a data warehouse, but you don't know the frequency when they're going to push it. There is no specific schedule. You can expect those kind of files. This could be CSV, Parquet, whatever files, right? Or any object, data object that can be pushed inside cloud S3 bucket, let's say in case of AWS. And you have a requirement the moment that data file arrives in this bucket. At the same moment, there should be some provision that this file get consumed and load into my database or data warehouse. That is called the event-based processing. And now moving to cloud, you get a lot of integration for it. So if you have heard about some kind of Lambda functions or EMR clusters, right? Those you can use, and you can just connect this cloud S3 bucket with this Lambda function. I'm just taking a reference of AWS cloud terminologies. Similar services are available in all the major cloud platforms like Azure and Google Cloud platforms, right? So what you do is you just create Lambda function, or you just write your ETL code here, and it keeps listening to this bucket. And the moment the file lands in this cloud bucket, this function get triggered and it consumes that file and load into again staging area, right? And so this is event-based processing, right? You are not scheduling your ETL tool, and it is not real time. It is more event-driven. The moment the file lands, it Lambda get triggers and it process that file, right? And it is very synchronous in nature. Now, third category of data consumption. I'm just talking about data consumption at this point of time, right? So these IoT devices, this could be your sensor, time series data. These are constantly emitting the data, right? So what you need is, let's say, for example, weather like heat, temperature, or maybe pressure sensor, those kind of sensors mounted, let's say, on some plants or some digital industries, wherever, right? And each second or millisecond, you never know, right? These are just constantly emitting the data. So you need some kind of real-time data pipeline, right? Wherein this data you can capture in real time and process it and load into your data warehouse. There comes some kind of queuing or messaging services. You can call them pub-sub services as well. So in the industry, people might have heard about Kafka or Kinesis in case of AWS. These are the pub-sub services wherein you can directly connect these endpoints to IoT devices, and the moment they record and emit data, these queues are smart enough to stack that data points sequentially up to some retention period you can define for, like, say 24 hours or 2 days, 7 days, whatever, right? So this is the way to capture real-time data. And on top of this queue or this real-time service, you can run some real-time analytics as well. So for example, you would have seen in case of, right, when you book a Uber, right, Uber ride, or any food delivery service you avail, right? Real time, they keep giving you status of that, where your cab is, right, and how long, what is your ETA. That works in the real time, and that's one of the typical example of these real time data pipeline, where you can think of the GPS device mounted on Uber car, let's say, right, that is constantly emitting the data. And that Uber data platform would have some kind of messaging services like Kafka, and they give you the real-time analytics to on your mobile phone. So it's like similar to that. But this is for analytics. But if you want to store this real-time data, then what you would do is you will use some kind of computing power. So in industry, you can use Spark streaming services, or you can run those services on some sets of compute clusters. So in AWS, they're called like EMR clusters. You can spin up. And if you want to, so this data is raw data, which Kafka is consuming is kind of raw data. But if you want to perform some kind of transformation on top of it, you want to enrich that data or do some quality checks, whatever, then you can do using Spark streaming and load that data finally into your data warehouse. Right. So this is the combination of batch, event, and real-time data processing. That's how you acquire the data. Now, coming to a little different topic, right? You would have seen some new thing, like you have this data warehouse here, but you have something called data lake, right? So this is also it's not always mandatory, but it's also important key component in terms of modern data warehouse design. It's called the data lake. So it's altogether, again, Alexei, it's a separate topic altogether, difference between data warehouse and data lake, but I'll just quickly briefly cover, right? So all sorts of structured data you tend to store in data warehouse, right? And if you have some kind of unstructured data, or let's say flat files, right, which you don't know how to consume in your current data warehouse model, so what you do, you just keep it in the data lake. And in future, if you have those needs, you can consume in the data warehouse. Otherwise, you keep in the data lake. And sometimes there are requirements wherein um, your data model is changing. It's not very stable, right? It's very robust, and so that you do not want to touch your data warehouse model. Rather, for those kind of loosely coupled data model, you just keep in the data lake. So practically speaking, right, I'm using this data lake currently in my current project, and a lot of flat files, CSV, Parquet files, we keep here in the data lake. And later, when we realize, okay, we can extract some value out of it, then we tend to process in the data warehouse, right? So now after data lake, you see one new component called DBT here, right? This I purposefully put here because this is in trend these days. It's nothing but it's kind of one framework to run your ELT workloads. So mind it, ETL is different, right? ETL, where you extract, transform, and load the data in data warehouse. And ELT, you extract, load the data. Let's say you extracted data from the source system, load it in the staging layer. Then you want to transform within the database. So how would you do that, right? Let's say typical methods, you can write some SQL queries to extract data from this staging and transform within the SQL and then load in data warehouse, right? So how do you orchestrate? So if your data warehouse solution goes bigger, right, you scale up, then you need some mechanism to maintain those SQL statements, right? And you want to set up some dependency, continuous CI/CD framework you want to implement. So this DBT, again, it's altogether a new topic itself. So this DBT helps to just keep your SQLs and stored procedure, whatever you're using, It helps orchestrate them, set some dependencies, right, and easy to maintain. So the full form of DBT is database tools. Some of you have heard about it already, and it really helps when you have your ELT kind of architecture, and it always comes between the staging and between the raw data and the transform data. In this layer it comes, right? And then yeah, so there are typical, I mean, there are different ways, right? So some data is coming from this staging, some data is coming from directly from streaming, and some of the data could be coming from data lake into the data warehouse, right? And now on top of data warehouse, again, you can have those you know traditional consumers like visualization, reporting, business people, right? Those people. And apart from that, right, you see some new component called DSML. DSML stands for data science and machine learning, and it we use this DSML for more advanced analytics, right? And mostly in most of the cases, um, the more amount of volume of data you can push to your data science and machine learning models, right, the more that model get mature. So they consume data from data warehouse, they're interested in data from the data lakes. So all these places, both of the places, they consume the data and then run their own analytics and train their model. So these are, in the modern data warehouse, these are also key consumers, which was not the case earlier when we were dealing with smaller data sets. One more important thing, as I mentioned, if you look at the previous slide, right, the consumers are also growing, right, who are interested in your data analytics. Right now, everybody wants analytics. Earlier, it was very few consumers, like business people, sales, marketing department, or maybe management level professionals, right? But now each and every retail consumers also interested in this analytics. So what you need is, you need some kind of mechanism, and also the volume of data is also growing at the same point of time. So you need some mechanism to search, should be able to search data in data warehouse, right? Because you're loading data from all the places, right? You need some kind of cataloging mechanism. So here I mentioned data catalog. This is just basically a way to search data within data warehouse, and you can search in the business terms. You have business glossary, all sort of thing, and any consumer can just log into data catalog, consume this and search by the data sets, let's say uh, stock prices, right? Or maybe the consumer index, expenditures, or any sort of business term you can search, and it reads the metadata from data warehouse and throw all the tables or views you might be interested in. So this is also a key component these days. So that is how, I mean, again, just to summarize quickly, you have various ways to bring in the data into your systems: batch mode, event mode, and real-time mode. And then you have data lake and data warehouse. Both can coexist. In some of the use cases, you only need data warehouse. For some of the use cases, you only need data lake. But if your data warehouse design is more comprehensive, then you would see, these both um, hubs or systems coexist, right? And these are all optional. You can use DBT, you can use traditional, let's say scheduling or orchestration tools, right? And yeah, then DSML, and these are the consumers who consume the data. Still, it is not, I would not say it's 100% foolproof, because you have a lot of different frameworks, like you need data monitoring, data quality checks, which are in all the time. You need certain alert mechanism to generate, right, and send it to your data engineering team if something fails, right? All these things comes into play.
So where do this data monitoring system, how does it fit into this picture? Would we monitor ETLs? Would we monitor, I guess, pretty much everything, right?
Yeah, everything. So basically, broader idea is you want to monitor this whole process. If something breaks at some place, you need some mechanism for alerts, right? It can be issued to relevant people and they can go and fix that. So whether it's ETL or maybe DBT layer, or maybe at the consumer level, right, something is breaking, So as a data warehouse professional, right, or designer, our job is to extract the data and deliver the data till consumer. That's whole responsibility lies with us.
Is it your last slide?
No, I have one more, but I would just took a pause if you have any questions, right?
I just don't know what is next that you have. Maybe it's related to what you already have. But I was wondering, so I heard this Lambda architecture. And so as far as I remember, this Lambda architecture is about having both streaming part, like online part, and then having the batch part. And I'm wondering if, like, how does Lambda architecture fit into this picture, and is it even related and relevant for the data warehouse design?
Yeah, so I'm telling this from the practical, example. So we are using this Lambda architecture quite heavily, right?
Is it
Combination.
the Lambda architecture that you showed, or?
So this is the event-based processing. This whole architecture is not based on Lambda, but only one component is there, which I'm
No,
using
I
for event
didn't mean
processing.
like Lambda functions. I mean there is this.
Serverless architecture, you mean?
No. I mean you have this Lambda architecture and cup architecture. This is a way for designing your data pipelines. So it has nothing to do with AWS Lambda.
Okay, that way. Yeah, I get it. I get it.
You know what I'm talking about?
So I get the Lambda architecture, but not the other one. Maybe you can explain a little bit. Yeah.
It's cup. I don't know. Like I don't know it myself. That's why I was hoping that you can explain it, because I read about this, so I think I might be wrong. But in Lambda architecture, you have so you have your source data, and then like you have on your picture, the source data comes into flat files that are generated like in batches, and then you have streaming data, a stream of events. And then you have different processes to handle this data and process this data. And yeah, then somehow they end up in the same data warehouse or in the same consumer.
In that case, I would not consider this architecture as a Lambda architecture. Yeah, it's not completely that. Yeah, it's just a small Lambda AWS Lambda function we are using, but that doesn't classify as a Lambda architecture. Yeah.
But just a small side note, I have no idea what I'm talking about when it comes to Lambda architecture. So this I just read somewhere. Yeah, we have actually some questions. So the first question is, where is the staging area in ELT? Does it exist with data warehouse products like Redshift? Does Redshift have a staging area?
Yeah, good question actually. Actually, I should have designed it much closer to data warehouse, because most of the time you will see this staging area is a logical entity, but in terms of the implementation, it coexists with your data warehouse product. Maybe it's Redshift, right? It could be different schema or different database altogether, but staging and data warehouse, these both physically coexist with the same data warehouse product, right? That Redshift, Snowflake, or whatever.
So basically, this is like the separation is in your head, right? Or in schema.
Yep.
So it's the same database. It's just you have like staging schema, and then you have, I don't know, production
Final,
whatever.
yeah, target schema, whatever. Yeah.
And so the data doesn't leave the database. So you load the data to your data warehouse, then you have dbt that takes the data from one schema, transforms it, and then puts to another schema, right?
Absolutely. And that uses the power, the compute power of your database itself.
There is a comment about this Lambda architecture, that there is a very good explanation of this on Twitter engineering blogs. So I haven't read Twitter engineering blogs, so probably I should check it.
Maybe you can tag this later in the description.
Yeah, maybe if you can send a link, so the person who posted Vacation Traveler, maybe you can send us a link, and then we will post it. I don't know, maybe you have some other slide, and then we'll...
Yep. Let's go there. Yeah. So so then this is the final last slide, right? So there's a term called data ops, right? It's a newly coined term, and I have been reading about data ops since quite some time. And somebody in my organization who just pointed me to data ops study, which some companies did, right? And so it's nothing but in simple terms, right, how you maintain and manage the modern data warehouse architecture efficiently, right? Those are the some recommendation and best practices. If you club them together, they are called as data ops, right? So some of the important building blocks, right? So in modern world, right, obviously you need your data warehouse to be designed in more agile way, right, more flexible way. So all sorts of, so you need to break down this architecture in various pieces in different phases, right? So first you will so this is more, data ops are more kind of best practices how you implement your architecture. And agile is, I think most of the people in this audience knows what is agile development, so I'll not spend much time there. But about CI/CD, right? So and the tools and technology which you use in these architectures, right? Most of the time when you're using cloud services, they are always you know uh, can easily be integrated with any CI/CD frameworks, right? And that is one of the main requirement when you design architecture. You have to think about deployments as well, right? And this is something which which used to missing in the traditional data warehouse designs, right? And data pipeline orchestration. And so in very simple terms, I can call it like creating dependency or scheduling your data pipeline. So when this batch job will run, how this DBT will get triggered, right? How this EMR will get triggered. So all these kind of orchestration and dependency has to be there in your modern data warehouse design. And some of the technologies you can use, like open source Apache Airflow, right? Or maybe if you're using AWS services, then step functions, and these things you can use to orchestrate a data pipeline. Now I want to focus on this fourth point, a little bit more in detail about metadata driven ETL, right? So this is kind of could be new term for some of you, right? So, and this is related to generic ETL, the term I have mentioned here. So what used to happen in traditional days, right? We used to create different ETL packages. Let's say I'm talking about enterprise ETL tool. So you have one ETL package to pull data from this source system, another ETL package to pull data from another source system. So those were more kind of point to point ETL because the data sources were limited in nature, and you could live with point to point ETLs and for individual source systems. But nowadays, I'll tell you, in my current implementation, we are getting data from almost more than 100 source systems, right? And maintaining those point to point ETL is not practical these days. So what we need is kind of generic ETL, and there are various framework to implement generic ETL. In simple word, you should have, you should be able to design your ETL in such a way that it is more modular in nature and it is configurable. So let's say today I have 10 source systems and tomorrow a new source system comes into picture. I should not be writing another ETL from scratch, right? I need some way wherein I can configure the metadata or the connection strings and format of that source system, and my same ETL code should be able to just pull data from that source system. And that is called the metadata driven ETL. And how we implement it is we have one config table. It's a simple relational table in database where we keep entry of each and every source system. So with multiple attributes, so like source system name, its connection string, connection type, let's say FTP, API, S3, whatever, and that its connection credentials and what kind of files or endpoint we want to hit, right? Any regular expression. So like 20, 25 attributes we have. And what this generic ETL does is it runs on daily basis and it keeps reading that configuration file, right? And once it reads the first row, it looks into the source system details, pulls the data from source system, because we have different modules inside this ETL. So based on the config file, it goes to that particular module, let's say FTP module or S3 module, right, or Salesforce module, and process the data and load into data warehouse. Once it is done, then it reads the second source system, third source system. That way, when a new source system is there, right, to pull data from, it's just a task of maybe like one or couple of hours, right? Just to configure new source system, test it, and deploy it in production. So you can scale integration of the various source systems if you design your ETL, which is more metadata driven. Again, metadata means that config table, which I explained, right? So you just have to make a new entry in your config table, and this ETL, when it runs, it it keeps reading those entries, right, and process your data. And that is very much required in the modern data warehouse design in terms of scalability and faster implementation cycles. And then data catalog, I already mentioned. You need some kind of elastic search mechanism so that you can search your data in more natural language, right, and get the objects which you are interested in. And one last thing, there could be many more, but I just listed these few. So data reconciliation framework. So some people call it data quality framework, etc. So wherein you just want to have some framework where you can see whatever amount of data you are consuming from source systems, you are not losing that data in between, right? So basically you need some mechanism to reconcile data after you load in the data warehouse. So from within data warehouse and the source system, there should be some mechanism to reconcile that data and get some reports if you are losing some data or not, so data availability is fulfilled or not. So these kind of components are make your modern data warehouse architecture more robust, more efficient, right, and serves various category of consumers. So you can read more. I mean, I'll ping you a couple of studies. They're a very huge study and more tangible, right, in terms of some samples some of the organization did, and you can just mention it in the description of this video.
Yeah, please send all the links and we will put them in the description.
Sure. Yeah. So I think, yeah, that's it. I think I'll be open for more questions now if you have.
Yes, we have quite a few questions, and actually I probably should share my screen. It will be easier for you to read the questions this way.
I'll stop sharing, yeah.
Yes. So we have 6 questions. And the first question we have is, can you explain dbt more? How to create dbt scripts? And before you attempt to answer that, I will do a shameless plug, because we have a data engineering course, and one of the modules there in this course is actually about dbt. So I don't know, Rahul, if you'll be able to answer that question now about dbt, but there is a longer in-depth introduction to dbt in this course. So if you're interested, check it out. It's on GitHub, Datadog/data engineering zoomcamp, so you can check it out. And yeah, maybe now the end of shameless plug, maybe you can attempt
I think good you mentioned about this resource, right? Because I think it's difficult to explain like dbt in short time, but I'll just attempt in a minute or so, right, in 30 seconds. So basically dbt comes into picture when you just want to transform data which exists within the database. So between staging layer to data warehouse, right, between two in the same let's say data product, you have two different schema, and you want to move data from one schema to another schema, right, one raw table to, let's say, final table. So what you do, you will write some SQL scripts or maybe some stored procedure, right? Now when you are dealing with hundreds of table or more tables, right, then you will have those 100 SQL scripts or more than that, right? In order to manage those scripts, manage those dependencies, right, there is a framework. That framework is called dbt. There is more into it. I think you check out this course which Alexei mentioned, right, and you will get more about it. Yeah.
And dbt, it's quite a popular tool. So if you just go to Google or your favorite search engine and look up something like getting started with dbt, you'll find quite a few resources. So yeah, it's a popular tool. There is a lot of learning resources, including the course I mentioned. And yeah, there is a question how to enroll in this course. And the answer is you just check the repo I mentioned, and then in the README at the beginning it says what you need to do. So you don't need to formally enroll. All the videos are available there. So you just click on the week that you're interested in and you start watching. Like everything is published on YouTube, so you don't even need to formally enroll. So I don't even.
I believe this is.
Yes.
I believe this is self-paced course, right? Which people can watch
Yeah,
with their own
I mean
flexibility.
it's kind of both. We did this as a cohort, so we started in January, but now the cohort is almost over. But yeah, so there is a description how you can take this as a self-paced course, and yeah, all the videos are here. So you just click on the week, and then yeah, click on this thing, and then it brings you to YouTube, and that's. You don't even need to have a YouTube account. I don't know if it's. Yeah, I think you can watch. I don't know if there are people who do not have a Google account. Probably there are.
There could be.
You don't even need that.
Yeah.
Okay, next one. How do you partition 10 terabytes of data?
For processing, right?
Yeah.
Yeah, I mean, there is no single answer to it. Basically, you know, in your ETL layer, right? You can decide. Let's say if your data size is too huge, you can just partition it by, let's say, date or maybe like timestamp. That's the best way it works, right? And you know, because you keep logging this in the audit table, how much since when to when you process that data, that time duration, and you keep reading your audit table and process the next set of data. But mostly this I mean, if you're talking about database partitioning, right, that comes into play when your data is already loaded in the data warehouse, right, and you want to consume that data. Then you have different mechanism, right, like in traditionally we used to do indexing, etc. But this new cloud-based data platform, they have something called clustering, right, or maybe auto partitioning. A lot of them, these comes as out of the box services, but still as a database developer, you can use these clustering keys, etc., to partition, and these mechanism varies for different vendors and products. Yeah.
I think the most common one is partitioning by date or by day or by month. So depending
Absolutely.
on, say, if in each day you have a lot of data, I think you can also partition by hours. So for us at OLX, I think the most common way of partitioning data is by date.
Yep.
By a single day. Yeah.
Agree. Yep.
Okay. I think this could be related to the previous one, right? So what is ideal Spark config for processing terabytes of data? Time is not an issue.
Node and executor, yeah. So again, this is not just a single data point, right, which decides the cluster configuration, like 10 terabytes of data. It depends, like, what's the complexity of your data processing, right? If you have very huge, complex transformations or maybe alterations, right, then you need a more compute power, and thus the more clusters, right? But again, I mean, I'm afraid I could not, I cannot answer. I mean, there's not one straight answer, right? It depends on the complexity of your process, right, and processing.
So if you need to join this data with some, like if you need to enrich it and you need to join with another big table, which is 10 terabyte, the answer is very different from if you just need to do a map over this 10 terabytes of data, right?
Absolutely.
So it really depends on the use case.
Yep.
With a lot of data sources that we need to collect, can you suggest an ideal way to store such data? Not to mention if data is growing, it will be a headache for us.
Where to store such data? Yeah, I think that's what in the modern data architecture, right? You have these days, you need not to estimate the storage in advance, right? You have these cloud storage, and those storage are very cheaper, whether you go to Redshift, Snowflake, or BigQueries, right, or Teradata. Storage cost is not an issue, and you get unlimited storage in these. So I think rather what I have seen in the practical real world use cases, you're more worried about the compute power than the storage, right? So if the data source is growing, I mean, one thing I could say is, if you have some kind of restriction on your data warehouse, just keep storing that data in data lake, maybe in form of flat files or as a raw data, right? And later you can figure out how to manage that storage. So combination of both these technology helps you solve the storage problem as well.
I think it's pretty common just to dump data on S3,
Yeah,
i.e. data lake, and keep it there until you figure out what, like how exactly to process this data and put this to a dashboard.
Absolutely. Yeah.
And with S3 as well as other object storages, you have different ways of storing it. Like you can tune it for your need, like depending on how frequently you access this data, right? You might choose one option over another option. But if you, let's say, if you access it frequently, then yeah, you need to use a different thing.
Mm-hmm. Yep.
Okay. How do you move data from staging to data lake?
Staging to okay, this arrow, right? I think.
Do you want to share your screen, maybe? If it will help, let me stop sharing.
I mean, yeah, let me do that. So I think. I think people are referring to this particular arrow, right? Staging detail. I think this is, I did it in maybe by mistake or so, but it's most of this, in most of the implementation I have seen, you do not move data from staging to data lake. Rather, you move it from directly from S3 bucket or some other places from the source system directly to data lake using the ETL or event processing. But if you have this some data in staging, most of the cases you do not need to move it to data lake itself. I mean, do you have any other thoughts, Alexi, here? With the
I mean, I know that technically, let's say you can use Spark or whatever to connect to your data warehouse, then pull the data out of your data warehouse, process it, and then save to S3. But why would you do this? I don't know.
Yeah, I mean, that's what I mean. That's my bad. Actually, this row is this arrow is a little misleading. That's why I think people have this question.
I think actually, yeah, I can think of one reason why you would do this. Because I'm thinking about OLX. So we use usually data warehouse more for data analytics and BI, business intelligence, and these things. But for running machine learning workloads, we try to move the workloads, these jobs away from the data warehouse. Right? So they don't put load on the warehouse. For that, we have a job that is executed during the night when analytics do not run the queries. We pull some data from there, and then we run our machine learning stuff on top of data in the data lake. But it was prepared, the data was prepared by analysts in the data warehouse.
Got it. Yeah.
Maybe it's like, I don't know how typical this example is, but this is what we have because we don't want to get computation from analysts when they need it. So we run our queries on top of data lake.
Okay. Yeah, but I mean, yeah, that seems to be a valid use case. But I think in general, you would not want to move data from staging to data lake. So just ignore this, guys. I mean, this maybe by mistake or so. Yeah, I'll stop sharing, Alex. You can take next.
Yeah. Tell us more about the approach in which you have config table. What process happen daily when the scheduler reads the config table?
Yeah, so scheduler doesn't read the config table directly. Scheduler triggers the ETL job. And in the ETL job, very first function is to read that config table one by one. So first row it reads, and so for example, it gives you information in the first row of source system, which is, let's say, Oracle source system. So it will say Oracle and then give you the connection string, host name to that source system, credentials, and which database in Oracle you want to hit, which schema, which table you want to onboard. These all information I have. This is a source information, right? I have in the config table, and my ETL job reads that config table and triggers the specific module within the ETL, right? So we have a lot of decision trees, right? And that's how ETL jobs our generic ETL jobs keep reading this config metadata table and onboard the data from each source system one by one. That's what I mentioned about same thing, like metadata driven ETL.
Do you know a good source that people can refer to learn more?
See, to be honest, I'll tell you, when we designed it, we did not know this term, right? And we designed it such a way. But I was explaining this to, some other meeting or, webinar. Then somebody told me, that, oh, this is metadata driven ETL. And I said, okay, wow, I did not know that. This is something that organically we designed in such a way. But
Yeah,
I have
maybe
not
you
read
come
any.
across something like a blog post or a video that explains this concept and shows how to have such a thing, how to create such a thing, or
Yeah,
maybe if you at some point decide to give a talk about this,
why not?
share a link with us.
Yeah.
Yeah. So let's move on. Do you think in the coming 10 years the whole big data engineering will be automated? Um, if yes, what is the next thing one can learn, or what is the future? What the future will be? So, do you know what the future
Uh,
will be?
no, I hope, I wish I know. But I think same thing, when we were working with traditional sources, right? People were thinking, okay, what after Informatica or what after talent, right? But this new thing came into picture. We don't know. I mean, later when quantum computing or whatever comes, or metaverse, these days Web3, we will have some other architectures in those on those technologies, right? So yeah. But I mean, honestly, I don't. I mean, do you know, Alexei? I mean, I would be interested in knowing.
No idea. Like if I knew, if I had an oracle, then maybe I would consult it and ask. Like, should I buy Amazon shares now? Will it be more expensive in 10 years? I don't know.
Yeah, same thing. Same thing.
Okay. How do you handle transformation in metadata-based ETL? The T part
Yeah.
will need to be customized for every source, so I can include it in the config table.
Yeah, that's very good question. Actually, we had a lot of discussion when we were designing this. So obviously, E and extract and load is easy, right, to configure there. But what we are doing currently is we have still we are maintaining that transform. We are not using. We are doing a lot of POCs on DBT. Still, it's not in production. So what we are doing currently is in config table we have one more column wherein we store the stored we store the stored procedure call, right? So we have a stored procedure which moves data from staging to a target table and transform in between. And those stored procedure call statement we have given in the config table. So when ETL executes, it loads the data in staging. After that, it calls that stored procedure, which moves data from staging to target table and transform it. So kind of we are kind of mimicking DBT in our config table, and yeah, that's how we are storing those SQL calls.
Can you talk a bit about testing in ETL? How to unit test data sources, transformations, etc. Can you even do this? Like, can you unit test data sources?
That's tough, right? Because I mean, you can do up to some extent about test this when it comes to internal data sources, which somebody in your organization, right, owns it, and they know what kind of constraint you have, right? But in this modern data world, right, you have a lot of data, third-party data sources or public data sources, which you cannot test, right? You don't know their SLAs, their protocols most of the time. So what you can test is you can do data reconciliation, right? That's in your boundary. So you can test whatever data you are getting from the source system, that data is going into destination or not. That's what you can test, but not the
Because it's
data
something we
sources.
talked about in the podcast, right? Data reconciliation. So
Exactly.
let's say you get in, I don't know, 1,000 records. You expect to have 1,000 records in your target
Hmm.
database, right? So if this number is off, then something is wrong, right? Or maybe you have some deduplication, but you
Yeah,
also
yeah,
want to see that, okay, we expect to have this number at the end, but this number is different. Why is it the case, right? And
exactly.
I think what is also typical for these situations when the data comes from some external sources is to have monitoring. So let's say today you get less data than yesterday, and then you
Hmm.
get an alert, hey, something happened, today you have 30% less data than yesterday, and then you start digging into this and see, okay, is it a problem or it's just because today we have fewer records? right? And then maybe you can ping the data producer and ask them, hey, well, what's up?
Yeah.
So I think this is how it's typically solved. So not on
Yeah.
testing level, but more on monitoring and alerting level.
Absolutely. You have expected, and you have expected metrics, and you have actual metrics, and you just compare it, and just go about it.
Okay, so ETL or ELT or ETL, which is more trending or practical according to you?
Trending, I like that word, right? So I think again, it depends on use case. If you have dealing with huge data, big data, and volume of data is so huge, and you can afford to have transformation in your database, right? Data warehouse, if it's that robust and scalable, then I think you can go with ELT, because it gives you a lot of flexibility of having your data model loosely coupled with each other, right? Those tables. So ELT make more sense in those cases. But if you have some use cases where you have a lot of certainty about data structure and data models, your everything is like so much certain and fixed, then you can go with ETL approach. Yeah.
So again, the answer is it depends.
It depends.
This is what is trending. Answering it depends on most of it. Sorry.
Yeah, true.
There is no silver bullet. But I guess so for ETL, the thing you lose is you lose the raw data, right? Because you transform the data and you load this to data warehouse. So if you want to go back and recalculate, you might have problems, right? And
Yep.
you need to think, okay, can I be in a situation when I will need this? If yes, then maybe it's better to store the data. If no, let's just transform then and load the transformation.
Yeah, and most important thing in ETL, right? Sometimes you don't know how you will or use that data, right? How to load that, fit that data into data warehouse. That's where you keep moving towards ELT. Okay, just let's have that data first, and later we'll figure out how to use and fit into data warehouse.
Okay, I see that we should be wrapping up. Do you have time maybe for one more question?
Yeah, sure. Let's take it.
So the question is, what are the use cases of a data lakehouse trending these days?
Data lakehouse. I mean, not sure about this term, but what I anticipate is it's combination of data warehouse and data lake, right? When they coexist. I mean, that's what I can figure out with this term. I don't know if you know Alexi better, then maybe you can pitch in.
I know that there is a data lake from Databricks, or sorry, lakehouse from Databricks. Lakehouse, Databricks, yeah, this one. But yeah, I think the main idea there that, yeah, as you said, you kind of have combination of both.
Yeah.
I haven't used it personally.
Okay, so I can relate to it now, because we currently using Snowflake as a data warehouse, and it has both the capabilities, right? You can have data in a structured format as a tabular format, and the Snowflake also provides some kind of layer where you can store your raw data, or in terms of those data files. So at the same product, if it provides both the functionalities, then I think that we refer as a data lake house. It could be like your Databricks or any other products.
I think one thing with data lake, it's usually immutable. So you write something there, and then you cannot go there and change a record, right? So it's either there or maybe you can delete it.
Yep.
In data warehouse, on the other hand, you can. So usually you do update, and I think the lake house is kind of a combination of both. So you have this sort of immutability, but then you can update records, but then you can also go back. So you have this versioning of data.
Mm-hmm.
So I think this is the main idea behind Lakehouse from Databricks, that you kind of have both from both worlds. So you have immutability of a data lake, and then this is, maybe it's file based. I don't know if it's Parquet or not. Yeah, I saw a demo. Also, it was one of the webinars here when there was an example of data versioning with Lakehouse from Databricks.
Okay. Yeah. And this term is new to me. Maybe I'll read more about it. Yeah.
Mm-hmm. Okay, I think that's all for today. So thanks a lot, Rahul. Thanks again for joining us today, for sharing your expertise with us. Thanks everyone for joining us today as well. So at some point we actually had 200 people joining in. That is probably the new record for a webinar. I don't think we had such a popular event before, so thanks again. Thanks everyone. And yeah, it was super useful to me personally, and I see many people wrote the same, that it was very useful. They say great presentation, so I fully agree. Thanks a lot.
Thank you so much, Alexei, for inviting me again, and I would love to share this knowledge. Yeah. And thanks everyone for participating and taking out time. Right.
So have a great rest